Hello friends, welcome to my channel. This is Fluid Mechanics Part 13 Isro question paper from 2006 to 2016. Question is, both pressure and velocity of steam drops in the moving blades of both pressure and velocity drops. In impulse turbine, no pressure drop. Then in reaction turbine, both pressure and velocity of steam drops in moving blades. So C is our answer. A model of a golf ball is to be studied to determine the effects of the dimples. A sphere 10 times larger in diameter than an actual golf ball is used in the wind tunnel study. What speed should be selected for the model to stimulate a prototype speed of 50 meters per second? Here it's wind tunnel study. So we will use Reynolds number. So data given are a sphere 10 times larger than actual golf ball. So diameter of model by diameter of prototype is 10. Diameter of model is 10 times more than the diameter of actual golf ball. So prototype speed also given. V prototype is 50 meters per second. For model study in wind tunnel, Reynolds number should be same in both cases. Reynolds number of model equal to Reynolds number of prototype. So Reynolds number we know, rho Vd by mu of model equal to rho Vd mu of prototype. Rho cancel, mu also cancel, then Vm dm equal to Vp into dP. We have to calculate Vm. Vm equal to Vp into velocity of prototype into diameter of prototype divided by diameter of model. Vp given 15 to dP by dm, it's 1 by 10. Here dP by dm is 1 by 10, so 5. Velocity of model is 5 meters per second. So B is our answer. A spherical balloon is filled with helium at sea level. Helium and balloon material together weight 500 Newton. If the net upward lift force on the balloon is also 500 Newton, what is the diameter of the balloon? A buoyancy question. So first data given, W is equal to 500 Newton. Net force is, this is upward, 500 Newton. What is the diameter of balloon? We have to calculate the dia of the balloon. We know buoyancy force Fb is equal to volume of fluid displaced into rho g. Here the fluid is air, so rho g air. F net also given 500 Newton, so F net equal to Fv minus W. First I will draw the diagram. Here FB is upward force of buoyancy, downward is W, and net of uplift T equal to net uplift. So from here 500 equal to volume of fluid is 4 by 3 sphere, volume of sphere 4 by 3 pi RQ into rho G air minus 500. So 1000 equal to 4 by 3 pi RQ into air density, you have to remember 1.2 kg per meter cube into G is 9.8. So RQ equal to 3 into 1000, 4 into pi into 1.2 into 9.8. Here if we will calculate this one, R will get around 5.4 meter. So from option A is our answer. What is the diameter? Diameter we have to calculate. R will get equal to 2.7 meter. From here diameter, this is the value of R. Diameter is 5.4 meter. So 5.42 meter, little bit difficult because without calculator getting root Q. One more thing is here, because T direction I am drawing it downward. Here if you pull the balloon with a string, the tension in the string, that is called as net upward lift. So it's a reactive force, so it will come downward T. Otherwise you can, here also you can do T net, then you will get T net equal to W minus FB. Same answer you will get. A jet of water issues from a nozzle with a velocity 20 meter per second on a flat plate moving away from it at 10 meter per second. The cross-sectional area of the jet is 0.01 meter square and the density of water is 1000 kg meter cube. The force developed on the plate. This is the plate with initial velocity small u. This is final. Water jet is striking. So initially relative velocity is v minus u. Finally also it's v minus u. So v equal to 20 meter per second, u equal to 10 meter per second. The cross sectional area of jet A equal to 0.01 meter square. Density is 1000 kg per meter cube. force is equal to rate of change of momentum. So m dot into Vx1 minus Vx2. Initial velocity minus final velocity. So rho A to V minus U, this is the jet striking velocity, into V minus U. So we will get rho A V minus U square. Put the values, 1000 into 0.01 into 20 minus 10 is 10. So we will get this is square. So we will get 10,000 1000 Newton Fx. So from option A is our answer. The laminar boundary layer thickness varies as here. For laminar boundary layer, delta by x equal to 5 by rex to the root over. So delta equal to 5x divided by rho vx divided by mu root over. So delta will varies as x to the power 1 by 2 in case of laminar, and in case of turbulent, delta varies as x to the power 4 by 5. Both are important, laminar and turbulent, for all examinations, GATE, IAS, Isro and other PSU also. The extent of pressure produced due to water hammer depends on A. Velocity of flow of fluid in the pipe, B. Length of pipe, C. Time taken to close the valve, gradual or quick closure of the valve, D. All of the above. It depends on all of the above. A Francis turbine running at 200 rpm develops a power of 5000 kilowatt under a head of 15 meter. The power output under a head of 100 meter will be how much? So data given are N1 equal to 200 rpm, P1 equal to 5000 kilowatt, and head in case 1 is 25 meter, head in case 2 is 100 meter. So power in case 2 we have to calculate. First we will calculate N2, then we will go for P2. We know head is proportional to N square and D square. This relation we will use here. H1 by N1 square D1 square equal to H2 by N2 D2 square. D2 is same, so cancel. Then C square. N2 square equal to H2 by H1 into N1 square. So H2 is 100, H1 25 into N1 square is 200 into 200, 25 into 4, so 16 into 10 to the power 4. This is N2 square, so N2 is 16, this is 2 into 200, it will come 400 rpm. Then we will go for power. We know power is proportional to nq and proportional to d to the power 5. For power calculation we will use this one. So P1 by N1Q into D1 to the power 5 equal to P2 by N2Q into D2 to the power 5. DD same, so cancel. P2 is N2 by N1Q into P1. So N2 we got 400 by N1 is 200 whole Q into P1 is 5000 kilowatt. So 8 into 5000, so we'll get 40,000 kilowatt. P2 equal to 40,000 kilowatt. From option C is our answer. A small plastic boat loaded with pieces of steel rods is floating in bathtub. The cargo is dumped into the water, allowing the boat to float empty. The water level in the tub will be how much? This one already discussed. You can do this experiment in your bathroom. You put any heavy metal inside that. Take a small plastic bucket and put it inside a full bucket of water. Inside that small bucket you keep one heavy object. Then you remove that heavy object and put it inside that big bucket. You can check the water level. It will fall. This is a big bucket and this is small mug. You keep one heavy object like steel rod or iron piece. Then second case, you keep that steel rod. Inside that this fluid is water. In both cases it's water. This is small mug. You will see water level is decreasing. So B is our answer. Viscosity of water in comparison to mercury is, so viscosity is dynamic viscosity of water, viscosity of Hg mercury. For water at 20 degrees Celsius, it's 0.01 poise, and for mercury it's 0.016 poise. So viscosity of water comparison to mercury is lower. B is our answer. Prod number is significant in a supersonics as with projectile and jet propulsion, full immersion or completely enclosed flow, as with pipes, aircraft, wings, nozzles, etc. C. Simultaneous motion through two fluids where there is a surface discontinuity, gravity forces and wave making effect as with ship's hull. Gravity force is important here. I will tell you Froude number. This is very important for IES and Isro exams. Inertia force by gravity force whole root over. So inertia force is ma, gravity force is mg. Cancel. Then acceleration due to gravity is length for time square into 1 by g root over. So multiply length here and divide L length whole root over. Length into then length square by time square into 1 by Lg. Length by time is velocity, so it's velocity square by Lg whole root over. So finally Froude number we will get V by root over Lg. This is very important. When problem they will give, they will ask for velocity or length. That time you have to use this formula. V is proportional to root over of L. Next question. The purpose of surge tank in a pipeline is to smoothen the flow of water, minimize the friction losses in pipe, prevent occurrence of hydraulic jump, relieve pressure due to water hammer. It relieves pressure due to water hammer. Surge tank in a pipeline. If it is a dam, pipeline, here turbine setup. So surge tank, here you will get small tank. This area is turbine. If you suddenly close this one, then that back pressure of water will go up here. So that sudden pressure rise is relieved by surge tank. Head loss in turbulent flow in a pipe. This is very important for IAS examination. HF is proportional to V square. HF is proportional to in turbulent flow, inversely proportional to d to the power 19 by 4. Then friction factor, F is proportional d to the power 1 by 4. In this question, head loss in turbulent flow in pipe varies directly at velocity? No. Varies approximately as square of velocity. C is our answer. This one. This one also important in terms of diameter. In friction factor, this one also important. Head loss is HF. A model of hydraulic turbine is tested at a head of 1 by 4th of that under which the full-scale turbine works. The diameter of the model is half of that of the full-scale turbine. If n is the RPM of full-scale turbine, then RPM of the model will be how much? So, similar turbines. Head of prototype by head of model is 4 and diameter of model by diameter of prototype is 1 by 2. It's half of the full scale turbine. So then n equal to RPM of full scale turbine. So RPM of prototype given, we have to calculate RPM of model. We know these three relation I already given. power, head and discharge. Discharge is proportional to n, head is proportional to n square, power is proportional to nq, and discharge is proportional to dq, head is proportional to d square, power is proportional to d to the power 5. This is very important for all examinations. In this question you will use this one. H is proportional to n square d square, so h by n square d square is constant. So here we will do h by n square d square of prototype equal to head by n square d square of model. So nm by np whole square equal to head of model by head of prototype into diameter of prototype divided by diameter of model square. So nm we have to calculate RPM of that model. It's hm by hp head of model by head of prototype into dp by dm into np speed of that prototype. So nm equal to hm by hp, it's 1 by 4 from here, 1 by 4 root over into dp by dm, here it's 2, np is n, so 1 by 2 cancel. RPM of the model is n, same as prototype. So option C is our answer. Consider steady, incompressible and irrotational flow through a reducer in a horizontal pipe where the diameter is reduced from 20 cm to 10 cm. The pressure in the 20 cm pipe just upstream of the reducer is 150 kilopascal. The fluid has a vapor pressure of 50 kilopascal and a specific weight of 5 kilonewton per meter cube. Neglecting frictional effect, the maximum discharge in meter cube per second that can pass through the reducer without causing cavitation is how much? So data given are D1 equal to 20 cm, 0.2 meter, diameter at 2 is 10 cm equal to 0.1 meter, P1 given 150 kilopascal, 150 into 10 to the power 3 Newton per meter square. Vapor pressure or P2 is 50 into 10 to the power 3 Newton per meter square. Specific weight rho g is 5 into 10 to the power 3 Newton per meter cube. Maximum discharge you have to calculate. First we will calculate velocity, then from there we will calculate the discharge. Bernoulli's equation we will apply here. So P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho G plus V2 square by 2G plus Z2. Z1 Z2 cancel, G no need to cancel, so we'll get here P1 minus P2 by rho G equal to V2 square minus V1 square minus V1 square by 2G. From here V2 square minus V1 square by is equal to 2G, take left side, 2 into P1 minus P2 rho G into G. So put the values, V2 square minus V1 square equal to 2 into G is 9.8, P1 is 150 minus P2 is 50. This is in kilopascal, so multiply 10 to the power 3. Rho G given 5 into 10 to the power 3, 10 to the power 3, 10 to the power 3 cancel. Then 2 into 9.8 into 100 by 5, it's 20. So 40 into 9.8, it will come 3920. Put the point here, so 392. This is V2 square minus V1 square, and from continuity equation we have to calculate A1 V1 equal to A2 V2. So pi by 4 20 square equal to, sorry, V1 we have to multiply, pi by 4 21 20 square into V1 equal to pi by 4 10 square into V2. So it's 4V1 equal to V2. So this is 1, this is 2. Put the values of equation 1 in equation 2. We'll get 4V1 square minus, this is square, equal to 392. So 15 V1 square is equal to 392. So V1 square equal to 392 by 15. It will come 26.1, nearly 5.1 meter per second. So for discharge calculation we will do Q equal to A1 V1. A1 is pi by 4 0.2 square into V1 is 5.1. Pi by 4 into 2 by 10 into 2 by 10 into 5.1. 4 cancel. 5.1 is into pi. 16.014 divided by 100. So Q equal to 0.16 meter cube per second. So from option 0.16 meter cube per second. B is our answer. Thank you friends. Thank you for watching my video. If you like my video, then subscribe it and share it with your friends. Thank you.